Please tell me, give an example of finite vector space. At least try to make one vector space. How one we can make vector space? Suppose you have one sets V, okay? You have one sets V and one vector space, one field is there F, okay? This is a set, non-empty sets, okay? This is a non-empty sets, non-empty sets, and this is your field, okay? How one can make a vector space with these two sets? These sets may be finite or infinite, whatever. How one can make a vector space with these two sets? My question is how one can make a vector space with these two given sets. Yeah, please give me the answer. At first, please tell me what is the definition of vector space. I think you forgot the definition, or you are not connecting with that one also. I think it might be happen. What is the definition of vector space? Risu?
So if a set can satisfy two operations, vector addition and scalar multiplication, then the set is called as a vector space.
Mm, yeah, suppose you have two operation. One is addition, okay? This will from your B, and one is multiplication, scalar multiplication, okay? It's from F V to B. Yeah, suppose you have these two operation on V, and under this operation this V satisfy some following condition, okay? Then we will say that V is a vector space, okay? So now we can in previous lecture we saw that what do you mean by generating set, what do you mean by independent set, so what do you mean basis. So I think you should try with the generating sets. What is the definition of basis? What is the definition of generating sets? What is the definition of generating sets? That set will generate the vector space. One set which will generate the vector space. What do you mean by generate? Yeah, this is what the notion of generate. At
The
is
element
yeah.
that can generate by the and any other element that can be generated with the help of the elements of which are present in a set.
Yeah, suppose we are saying that A is a one set A is a generating set of V. Then every element of V can be written as linear combination of the elements of A. Okay, so we'll try the uh, yeah. So we'll use the notion of generating sets, okay, here to produce a vector space. So yeah, take the collection, okay, this collection Ci Bi, okay, I equal to 1 to n. Okay, your Ci from F and your Vi from B. Okay, take the finite linear combination of V. Okay, so you can check easily that this is your this is a vector space. Okay, or 1 minute uh, I should write like that. Yeah, take alpha alpha. Okay, alpha belongs to a intersects, and this alpha is finite. Okay, mm, yeah, this will be more better. Okay, and alpha belongs to your intersects. It's fine. So we are collecting all finite linear combination of the elements of B. It is fine. It is fine. Is it fine or not?
Yes, sir.
Yeah, you can check this will form a vector space. Okay, and please tell me what is the basis of it. At first, please tell me what is the generating set of this vector space. Take give the name. Yeah, this is the take the name S. Okay, my question is, what is the basis? Yeah, what is the basis of what is the basis of S? This is my next question. Now, please tell me what is the generating sets of P, the generating of S. Clearly, na, this is the V. We are using these sets. We are taking linear combination of V. Okay, so every element of S can be written as linear finite linear combination of V. So your obvious answer is the generating set of S is V, and this is also linearly independent. You can check because all are distinct element, no one can be written as yeah, other linear combination of B. So your okay, your basis of S or 1 minute. Sorry, we don't need these things. We can talk about only generating set is fine. Generating sets of S, okay, is V. Okay, if all the element of V are linearly independent, that time we will say that this is a basis of S. Okay, otherwise one subset of V will be basis of this S. So now try to, yeah, so please tell me, yeah, what is the cardinality of this vector space? Is it finite or infinite? What is the cardinality of S? What is the cardinality of S? Yeah, please tell me. What is the cardinality of S? What do you mean by cardinality?
The number of elements present in the set S.
Yeah, what is the cardinality of S?
It should be infinite because Ci belongs to a field and field can be infinite also.
You're assuming that field is infinite. I did not field may be finite.
So if a field is finite, then the vector space is finite because there is a
Vector space is
finite.
finite. If your V is infinite,
Then it will be infinite.
yeah,
So it is both. If field is finite and vector space is finite, then we say no, V is finite. Then vector space is finite. If both are infinite and any one of them is infinite, then it will be infinite.
yeah. So what is the cardinality of S? This is depend on your non-empty sets V and the field F. Okay, is it fine? So if someone asks you, give an example of finite vector space. Okay, finite vector space. Then please let me one example or construct one example of finite vector space.
So if we take a field as a ZP, then it will be finite.
And V
ZZP.
and F both.
Yes, sir. I don't as think about V.
If
I
V is
want
infinite, then
if V is infinite, then cardinality is infinite.
yeah. So I am I want to know. Please give me one example of finite vector space.
Sir, ZP over
ZP over
ZP over ZP.
yeah, it's
Where
fine.
P is prime.
Yeah, definitely. Take V is your finite set, any finite set. Okay, and take V is a any finite field. Okay, sorry, I have to write like that. Take any finite set and take any finite field, then we done. Okay, so my question is, suppose your cardinality of V equal to n and cardinality of F equal to m. Okay, then what is the cardinality of the vector space? Vector space what is the cardinality of the vector space generating by V over F? Yeah, please give me the answer of this question.
Sir, N is 2 power M.
N or M?
N.
This is your answer.
Yes, sir.
Everyone agree with it? Anj, Riso?
Yes, sir.
Riso?
Yes, sir. I try to solve it.
Yeah, so write this, yeah, vector space generating by V over F like that. Okay, in this form. Okay, so how we can write this, suppose name, yeah, this vector space stuff, suppose take this is a S. Okay, so we can write like that: Ci Vi I equal to 1 to 1 to take some k. Okay, okay, means we can write C1 V1 plus C2 V2 up to Ck Vk. Okay, where Ck belongs to F and your Vk belongs to V. Okay, so what is the choice of this C1 C2 Ck?
Even has m choices.
And V1?
Even have n.
Yeah, then please give me the answer. Yeah, please give the answer.
Sir, since each VI has m choices,
Sorry?
n choice. Oh, each VI has n choices, and each CI has m choices.
Yeah.
So
Hmm.
total number of choices, sir, n is to me. First, sir, if we fix V for one C1 V1, only C1 V1, V1 has one choices, but C1 has m choices. So for
Yeah.
one m choices, and next V1 has m choices. So I think maybe n is to m.
Yeah, this your answer is correct, but I am telling Risu his time. Risu?
Sir.
Yeah. Could you understand?
Yes, sir, I understand. The answer is correct.
Okay, then fine. Okay, we are going to our next question. Okay. Yeah. So, what do you mean by vector space of polynomial? First, please tell me what is the definition of polynomial. What is the polynomial? What is the definition of polynomial?
Sir, an algebraic expression of variable whose powers are non-negative integers. I think
Sorry,
called
please tell.
polynomial. Ji sir.
Please repeat.
Sir, an algebraic expression of uh, variables whose powers are non-negative integers.
Yeah, please try to explain mathematically. Suppose you have one indeterminate x, or okay. So in term of x, try to give the definition of polynomial.
Sir, general notation a naught plus a1x plus dot 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 an xn, where n is belongs to uh, मतलब integer, non-negative integers, that is natural number including 0.
Yeah, and your coefficients.
Coefficients from the field,
Yeah, any field.
real number, any field, okay sir.
Yeah, no, we are talking about real number, but we can take any complex field also.
Okay sir.
Yeah. So a polynomial in a single variable. Okay, I'm writing the definition. Okay. Okay, a polynomial in a single indeterminate x. So what do you mean by indeterminate? I will tell you later. Okay, can always be written in the form, yeah, written in the form like that, an xn, okay, n minus 1 xn minus 1 up to a1x plus a0. Okay, oh my god, sorry, where a0 a1 up to n belongs to f. Okay, 1 minute. Yeah, where this coefficients a1 a0 up to n belongs to the field f, and that are called the coefficient. Okay, that are called the coefficients coefficients of the polynomial. Okay, and your x is indeterminate. Okay, so please tell me what do you mean by the word indeterminate. Yeah, so could you understand what is the definition of polynomial? Okay, a polynomial in a single indeterminate x, okay, can be always written as in this form, where your this coefficient are belongs to the field f. Okay, and if your and your n is a natural number, okay, including 0. Yeah, it's fine. It's a positive natural number including 0, or you can tell non-negative integer also. You can tell n is a non-negative integer. That time we'll say this expression is a polynomial in where x is a your indeterminate. So please tell me what do you mean by indeterminate. The word indeterminate means, yeah, please tell me what is yeah, try to explain what is indeterminate.
So which can have many values.
Yeah, so the word indeterminate means that x represent no particular value. Okay, so this polynomial satisfy for all x. It's fine. So any value we can put here in the place of x. So the word indeterminate means that x represents no particular value. Fine.
Yes sir.
Okay, so what is the degree of one polynomial? What is the degree of polynomial?
So highest power involved.
Yeah, so you can say, suppose your highest coefficients ak is non-zero, then yeah, k is your, this is the highest coefficient where k is a k is non-zero, that time k is the degree of that polynomial. Okay, so consider this one. Consider okay. Okay, I'll go through first finite case. Okay, yeah, please tell me okay, considering the set S. Okay, this is the set of all polynomials whose degree is exactly 2. Yeah, so please tell me this S will form a vector space or not? Does S is a vector space? Yeah, this is my question. What is collection? We are taking the collection of or set of all polynomials whose degree is exactly 2. Yeah, so please tell me, does X is a vector space or not over a field R? Okay.
No, sir.
Yeah.
No, sir.
Yeah, why?
Sir, because when we add two polynomial with one negative sign, so that will give us zero polynomial, which is not of degree 2.
Yeah, so answer is no. Okay, because yeah, what is the reason? We are taking, suppose take x to 1 and minus x to 1, so these two are belongs to these sets. Okay, so by the definition of your vector space, sum of these two should be in X, but when we are adding these two, okay, we'll get 0 polynomial, but it does not belongs to in yes. Okay, please tell me what is the degree of the polynomial 0? What is the
1.
what is the degree of polynomial 0?
Sir, 1. 0.
So 1.
So 0.
So not defined, actually. Not
Yeah.
defined, I think.
Yeah, not defined. Sometimes some author it is taking -1 or infinity. It is, but it's not defined in fine. Yeah, the degree of 0 polynomial is not defined. Okay, so right now I am yeah collecting. Take this one very important sets P and R. Okay, this is your set of all polynomials of degree less than and equal to n. Yeah, this is one sets. Okay, please tell me, does PNR is a vector space? Yeah, please tell me what is your answer.
Sir, PNR is the set of polynomials of degree less than equal to n.
Yeah, less than and equal to n.
Okay, sir. Sir, if we consider the zero polynomial as a degree -1, then it forms a vector space, but not defined in the condition of not defined, the zero polynomial included or not included.
Yeah, here
If
it
PN,
is
sir, if PNR included zero polynomial, then it
Yeah.
will be a vector space.
yeah, it will include the zero polynomial.
Okay, sir.
Yeah, so the answer is yes. Okay, this is a very important class. Please check that polynomial addition and polynomial multiplication is form sorry, not polynomial addition and scalar multiplication of polynomial form, yeah, satisfy the following condition of vector space. Okay, so you can easily check that conditions. Okay, so yeah, PNR will form a vector space under these two operation and over the field R. You can take any field, no issue. Okay, this is the yes. So my question is, what are the basis of PNR, standard basis? Yeah, please tell me standard basis.
Sir, can I tell?
Yeah, please.
Sir, 1, comma x square up to x to the power n.
Yeah, standard basis of PNR. Okay, 1 x square up to xn. Yeah, so when you are telling about that this is a basis of PNR, you have to check it is linearly independent or not. Already we, from the definition of polynomial, we can easily see that this is a generating sets. Okay, but you have to check it is linearly independent or not. Please try to check this one. Yeah, from the definition of polynomial, easily we can see that this is generating sets of PNR. Is it or not? Yeah. At first, please tell me you are agree with me or not. Is it a generating sets of PNR or not? Please tell me at first. Is this sets is generating set of PNR or not?
It is a generating set.
Yeah, from definition of PNR we can easily say that this is generating sets. Please tell me, is it
It is also independent because it is standard basis.
no? We will say that one set is a basis when it is generating set as well as linearly independent. So yeah, you have to prove that is it a generating set or not. Yeah, please tell me.
Yes, sir. It is generating set, sir. Okay,
Yeah,
sir.
so please try to prove
You can
that.
generate for any polynomial. Okay, sir.
Yeah,
Any
try to prove
polynomial, sir, can be generated with this set.
any polynomial. No, this is up to degree less than or equal to n. If you take n plus 1, then how you can generate? This is only for up to your,
Okay, sir. Okay.
yeah,
Yes, sir.
n.
Sorry.
Yeah, so
Degree up to 10.
yeah, this is obviously this is your generating sets. Okay, this is your generating sets of PNR. So you have to prove that is it a linearly independent. So for checking linearly independent, what is the process we know? We know the standard process, this one. Where Ci belongs to here the field R. Okay, I up to n. You have to prove that all Ci are 0 for or I belongs to, yeah, you have to prove this one. Okay, yeah, how do you prove this one? Please tell me.
since right hand side is a zero polynomial which can be written as 0 times 1 plus 0 times x dot 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 0 times of x of n, then we can equate both sides, coefficient both sides, then we can find the value of ci is 0.
No. Suppose you are taking x and minus x equal to 0. X minus x equal to 0. Okay. So there is your C1. Yeah, coefficient of x is 1 and minus coefficient of minus x is also, yeah, what, 1. Okay. That time how can you say that these two are, this coefficient are 0? Now this, there is one trick, because 1 x square power is different, so you have to take care of that. Everyone are familiar with derivatives?
Yes, sir.
Yeah. So Paul, I will know that derivative of every polynomial exists. Okay.
Yes, sir.
Everyone agree with my statement or not?
Yes, sir.
Okay.
Yes,
So differentiate both sides. Yeah.
Derivative for zero polynomial exists or not?
Yeah. This is a take is a constant function 0. We can treat
Yes.
0 as a constant function, no? So
Yes,
definitely, yeah, derivative exists. So differentiate both sides. Okay. At first, try differentiate. Yeah. Differentiate up to n time, n minus 1 times. Then what you will get? You will get c, the coefficient cn equal to 0. Okay. Then try to come the backward direction. After that you will get cn minus 1 equal to 0, or in other way also we can prove, you will get up to cn equal to 0 after differentiating. Okay. Or in other way also you can prove, put the value of x, this is true for all value of real number. Okay. This is your, yeah, previously I told this is x is a indeterminate, means it is, yeah, satisfy all the value of real number or complex number, whatever. Here we are talking about polynomial over the field R. So every real number will satisfy by this equation. So at first put x equal to 0, you will get c0 equal to 0. After that put x equal to 1, 2, like that. So you will get some equation, you have to solve. So in this, in that way also you can easily check that this is a linearly independent set, or I think this is a very easiest process to check this independent. Differentiate both sides. It's fine. Is it fine or not?
Yes, sir. Fine.
Yeah. Everyone are agree with me or not? Vijay?
Yes, sir.
agreed, sir.
Yeah. Risu?
Please can you solve it? I can't understand.
Yeah. Okay. So differentiate both side. Okay. If one if we differentiate both side 1 times, then we will get, what we will get? C1 2 C2 x up to n Cn x n minus 1 after one first differentiation. Okay. After first differentiation. After first different DFFERE.
After n differentiation, we got n factorial cn x is equals to 0.
Yeah, definitely. After your first differentiation. Okay. After second differentiation you will get something. Okay, after your nth differentiation, what you will get? N factorial Cn equal to 0. Is it or not? After your nth differentiation. Okay, this is after nth differentiation. Okay, so from here we can say that Cn equal to 0. Then go to backward. Okay, then you will get up to C1 equal to 0 and put x equal to 0 in this equation. Then you will get C0 equal to 0. Okay, putting the value x equal to 0, we get C0 equal to 0. We done. Is it fine or not? Yeah, please tell me.
Yes, sir.
Yeah, so this is your generating sets of PNR as well as linearly independent sets. So we can say that this is the basis of PNR. Okay.
Sir, one question.
Yeah, please tell.
Sir, as I solve equating the coefficient of polynomial, is this is correct or wrong method I use?
Yeah, when you are talking about identical polynomial, you are saying these things. It's fine, but we are trying to solve this equation.
Yes, sir.
Yeah, when
So
we are trying to
under
solve.
what conditions under what condition the method is fails?
Sorry.
Sir, how can I under which conditions I cannot equate the coefficients?
Okay. Now here you can equate the coefficients, no issue. But why you are not equating? This is the question. Is it?
Yes, sir.
Yeah. So why you are not? We are not equating this. Okay, 1 minute. Basically, we are trying to check is C0, C1, Cn, or we are getting some value of this one or not. Okay, so if we equate, then what will be problem? Mm.
Sir, I try to.
Yeah, I'll think about that. No, it's fine.
Okay.
Yeah, okay, I'll think about that. Okay. Now you can equate this to equation, but here we are trying to check this is independent or not in proper way. Okay. Yeah.
Yes, sir.
Yeah. Okay, I will think about that and let you know in next session. Okay. Yeah. So now consider. So this is your standard basis of your PNR. Okay. That obviously this is another take these sets. Okay, oh, please tell me what is the dimension of this one. Yeah, what is the dimension of this one?
N plus 1.
Yeah, so number of coordinate in these sets n plus 1. Okay, yeah, this is answer is n plus 1. Yeah, take the collection this one PR. Okay, set of all polynomials. Yeah, so this will form a vector space or not? Please tell me. This is a vector space or not? This is a vector space, set of all polynomials. Okay, add as set of all polynomials. This will form a vector space or not?
Yes, sir. Vector space form करेगा. Yes.
Okay, so what is the basis of this one? Standard basis?
1 x square up to x की power n up to continue sir, infinite मतलब वो continue जाएगा क्योंकि x की power में कोई restriction नहीं कितनी power
Yeah.
तक ही जाना है.
This is the basis of. So how do you prove that this is linearly independent? Obviously we can say this is a generating sets. Okay, so you have to check this is independent or not. How do you prove this is independent?
So can we try for small subsets of this set?
Please tell me
We
what
try
is
to.
what is the notion of independent sets for a infinite sets?
No, sir, I don't know how to check infinite set is
Yeah,
like.
so in first lecture I told about that. Okay, suppose a V is your infinite sets. Okay, infinite sets. So what do you mean by independent sets for infinite sets? Okay, so we'll take the collection of finite we will take the finite linear combination of from here. Okay, we'll take C alpha, V alpha, alpha belongs to this one, and take I equal to 1 to k. This is your finite collection, arbitrary finite collection from V. It is, you have to point out, arbitrary, okay, arbitrary finite collection from V. You have to take arbitrary finite collection from V and make it a linear combination. Okay, your C alpha I belongs to the field V, and V alpha I belongs to V. So take 0. So if you can prove C alpha equal to 0, then you done. Then we can say that V is linearly independent. Then we can say V is linearly independent. Okay, is it fine? Could you understand this one? V is your infinite set. We are checking that V is linearly independent or not. So we have to take the finite linear combination of arbitrary finite sets from V, and we have to check this equation. We will equate this equal to 0. Then we are trying to find coefficient is 0 or not. This is our aim. Yeah, understood, Vijay? Is it fine?
Yes, sir. Sir, this collection is arbitrary. Yeah, or fix some n.
Yeah, finite. You have to take finite, arbitrary finite set from V. Okay, they take linear combination of that, equate 0, and try to solve that coefficient is 0 or not. Understood?
Or sir, all alpha or,
Yeah.
or arbitrary.
For any arbitrary finite sets of V, you have to choose, you have to take A, arbitrary A, this should be finite. Okay, and take linear combination of A, and equate 0 and try to solve the coefficients.
So we done all. If we complete the complete that the set is Li, arbitrary set is Li, then the whole set, infinite set is Li.
Sorry.
सर इफ वी फाइंड दैट कि सर जितने भी आर्बिट्री फाइनाइट कलेक्शन है, अगर एक हमने कोई ले लिया उसका आर्बिट्री फाइनाइट कलेक्शन और उसको प्रूव कर कि वो एल आई है, तो सर उसका जो इनफाइनाइट वाला जो हमारा सेट है वो भी एल आई हो जाएगा फिर.
Now how? You are taking finite collection, not whole sets. Arbitrary finite collection from B.
ये सर फाइनाइट कलेक्शन उसमें से लेके फिर उसके उनको लीनियरली इंडिपेंडेंट प्रूफ करना है.
Yeah.
तो इससे जो इनफाइनाइट सेट है वो फाइनाइट मतलब वो लीनियरली इंडिपेंडेंट प्रूफ हो जाएगा.
Yeah, this is the definition of a linearly independent set for infinite set. You have to check, you have to take any finite subset of V and you have to check this finite subset is linearly independent or not. This is my, yeah. So we can give the definition like that. Okay, we are trying to say, we are trying to check V is linearly independent or not. Okay, so we will take, yeah, A is your any subsets of any finite subset of any finite subset of V. Okay, we will check A is linearly independent, okay, or not. If A is linearly independent, then we done. Then we will say that V is linearly independent. Okay, if A is linearly independent, then we will say that V is also linearly independent. Okay. Independent over the field, over the, you have to make sure that A and B are linearly independent over the same field. Okay, over the same field F. You have to make sure this one. Okay, you have to make sure the same field. Okay, so if A is linearly independent, then we will say that V is linearly independent over the same field F. Here use V is any finite subset of V. Okay, I am deleting this.
Yes, sir.
Yeah, understood right now?
Yes, sir.
Okay.
Yes, sir.
So check this is your independent set, this one. Try
सर
to
अभी
check.
इससे पहले आप एक एग्जांपल कराया था, वो सेम ऐसे ही था, बस उसमें फाइनाइट सेट लिए थे पीएनआर और फील्ड भी सेम थी. तो सर उसके बेसिस पे बोल सकते हैं कि ये इंडिपेंडेंट सेट होगा.
Yeah, you have to, yeah, so you have to use that concept. Okay, so we are checking that this set is linearly independent or not. Our aim is to check, yeah, this is independent, linearly independent or not. Okay, yeah, this is our aim. So take one arbitrary collection, finite, take the sets A, arbitrary. Okay, I am taking X alpha. Okay, alpha belongs to index sets and okay, and your this alpha is finite. Okay, now 1 minute. Take like that. Yeah, take like that. X alpha 1, X alpha 2, x alpha k. Yeah, this is a finite subset of this one. Yeah, okay. Is it fine or not?
Yes, sir.
Yeah, this is arbitrary. This is arbitrary. Yeah, I did not fix alpha 1, alpha 2, alpha k. Okay, it's arbitrary finite subset of this one. So if we can prove that this is linearly independent, then we done. Okay.
Yes,
Yeah.
sir.
So take C alpha 1, X alpha 1, C alpha 2, X alpha 2 up to C alpha k, X alpha k equal to 0. Okay, where your C alpha I belongs to the field sets. Okay, and this is already I mentioned. Okay, then how we can say that this I 0? How?
Differentiating, sir, using differential method.
Now try to use the previous notion, already previous concept. Yeah, we already know this one. This is a basis. This is an independence we already know. Okay, so try to use this concept and this result. Then what will be do here? Your alpha k is the maximum. Okay. Yeah. Okay.
Yes, sir. Any set which is linearly independent and any subset of that set is also linearly independent.
Yeah. We are checking this is independent or not. We don't know this is independent or not. Okay, so this is arbitrary collection of this one. So one things we can do, we can add this one 0 into 1, 0 into x up to, yeah, this is the your previous one. Okay, 0 into c minus 1 x alpha 1 alpha 2 all are integer, so we can, yeah, take minus. Okay, and C alpha 1 x alpha 1 up to C alpha k. Okay, sorry, in suppose in middle something is missing. Okay, between alpha and alpha 2 something is missing, suppose 2 3 term is missing, so we again will take 0 into that. Yeah, 0 into your next suppose this is your 5, will take 0 into x6. Okay, again we will take, suppose x7 is also missing, we will take 0 into x7. After that your x2 term will become sorry, x alpha 2 term will become so till now. Okay, if you continue this one, at least we will get the last term is this one. This is your last term. Okay, in between many 0 into x sum per maybe arise in between. Is it fine or not?
Fine, sir.
Yeah, in between.
Sir, one doubt, sir.
Yeah, please tell.
Sir, this alpha k is less than or equal to n. What is the relation between alpha k and n?
No, that's no relation. Yeah, you can look. This is the your infinite collection. 1 x xn up to dot 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 dot. It is going on.
Okay, sir.
Yeah,
Okay.
no relation is there. So you have to try to handle properly. Okay. In between some 0 maybe there. Maybe I don't know. Is between alpha k minus 1 and alpha k, between these two term some 0 into something may be there. So this is last n. So this is a nothing but a collection of 1 x up to x alpha k. This is a collection of if you collecting this coefficient we will get these sets. So already know this is linearly independent. You already know this one. Okay, so from here we can say that all alpha equal to 0 where your I is belongs to 1 up to. Okay, Is it fine or not?
Yes, sir.
Yeah, so this is your, yeah, this is your standard basis of PNR. Okay, then what is the dimension of that one? What is the dimension of
Sir, infinite, sir.
yeah, infinite? Okay,
But
yeah, please
but
tell.
sir, one question,
Yeah.
one more question, sir.
Please tell.
Sir, how to prove that this is the generating set of PR? But because the linear combination is always taken as the finite terms, I think.
Yeah, so take
So
arbitrary. Yeah, so our PR is a set of all polynomials. Okay, all polynomials
yes,
looks like Ci x bar. Okay, I'm taking this alpha I. Yeah, this is k. Your all polynomials looks like that. Agree or not? All
yes, sir.
polynomials. Okay, here C alpha belongs to F. All polynomial looks like that. Okay, so
Yes, sir.
yeah, your x alpha will belongs to from these sets. So what do you mean by generating set? Generating set will, suppose A is a generating set V, will take arbitrary element from V, will we can write that finite linear combination of the sets A. Any set of from some vector space can be written as finite linear combination of some sets A, then we will say A is a generating set. So any element of from these sets can be written as finite linear combination of this element. It is fine.
Okay.
Yeah.
Okay, sir. Okay, thank you, sir.
Okay, I don't have much more time, but I want to. There is some few interesting question is there at next session I will do, and I want to finish another one interesting question. Everyone are know about R2. Yeah, everyone I think familiar
Yes.
with this one. This is nothing but, yeah, our this space. This will form a vector space. Okay, under over the field R. We're talking about over the field R. Okay, and the usual, this is the usual addition and this is the usual multiplication, these two operation on R2 over the field R. We are talking about this one. Okay, so what is the standard basis of this one? Standard basis.
Sir, 1 comma 0 in the tuple 1 comma 0 and 0 comma 1.
Yeah, 1 comma 0, 0 comma 1. Okay, so could you please tell me what is the subspace of R2? What are the, not is the, what are the subspace of R2? What do you are familiar with subspace? Everyone are familiar with subspace or not?
Yes, sir.
Risu?
So please explain me.
Okay, Ans?
No, sir, I don't know that.
Okay, Rajesh?
Yes, sir.
Yeah, okay. So this is your interesting question. Before that, I have to recall what is the definition of subspace. Okay. Okay. Suppose given that you have the vector space V over the field F, this is already given. Okay, and we are talking about, suppose is a subset of V. Okay, S is a subset of V, non-empty subset. Definitely you have to take non-empty subsets, non-empty subsets of V. Okay, yeah, so we'll say that S is a subspace of V. Okay, if S form a vector space over the same field F. Is it fine or not? We say S is a subspace of V over the same field F, okay, if S form a vector space over the same field F. Okay, is it
Yes,
fine?
sir.
Yeah, it is fine or not?
Sir, fine.
Yeah. So what is there is one theorem there, okay, regarding how you will check this is a subspace of some vector space. You have to check all time. You can check the 10 properties. It is too difficult. So how easily you can check? Suppose you already know one vector space, yeah, familiar vector space, and you have to provide some subsets. You have to check it is a subspace of that non-vector space or not. How one can check easily? Okay, so one can easily check like that. Suppose take a subset W of a vector space of vector space V, okay, over a field F, okay, is a subspace of V, okay, if and only if, okay, sorry, if and only if when 0 is belongs to W, okay, and take W1 W2 belongs to W imply, yeah, I forgot to mention one things. Over the same field and same operation, you can change the operation, okay, over the same field and same operation, same field and same operation. This is the very important, same field same operation, okay. S is said to be a subspace of V, okay, we satisfy these three conditions, and C belongs to F, W belongs to W imply C into W belongs to W. This is the if and only condition. So if you combine these three, okay, if you combine these three, we will get like that, C1, okay, we are taking arbitrary, not C1, okay, take alpha U plus beta V belongs to W, where your alpha beta belongs from F, UV belongs to W, okay.
Yes, sir.
Is it fine? So now come to here, okay. What my question is, what are the sub spaces of R2? Yeah, please tell me, give us all and not one. Please tell me what are the subspaces. At first, please tell me at least one subspace of R2.
So zero subspace
Okay, 0, and after that,
and some trivial subspaces itself R2.
okay, is so one is 0, one is R2. So give me example of proper subspace. Yeah, I want to mention one thing.
Subspace when it is called as improper subspace.
Yeah, this is not a pop. I am telling about. Please give me one example of proper subspace. Okay. Yeah, here I want to mention one things. We are talking about a subspace of V. Okay. So every time dimension of subspace always less equal to dimension of the main space. Okay, is it fine or not? Because here we are taking the non-empty subsets from V. So every time if dimension of subspace is less equal to dimension of B, is it okay or not? Do you agree with me?
Yes, sir. Yes, sir.
Everyone agree with me?
Yes, sir.
Yeah.
Yes,
So,
sir.
yeah, please tell me what are the subspace of R2? You have to tell at first, tell at least tell one proper subspace.
Sir, the collection of all line which passes through the origin, I think,
Yeah,
forms a subspace.
yeah. Take this is your one line passes through origin. Take here is one point A comma B. Yeah. So yeah, this is your suppose take L. Okay. So L is generated by how? C into AB. Okay, where C is belongs to R and your this tuple definitely non-zero belongs to R2. Okay, this is your one line passes through origin. Okay, this is your arbitrary one line passes through origin. This is, you can easily check that L is a subspace of R2. If you take all collections, okay, if you were taking this one, someone can take this line. Okay, okay, you can take all line passes through the origin. Okay, all line passes through origin. Yeah, this will form a vector space of, this is form this will, at first you have to check that this line is a vector space or not. You at first you have to check. So if you take 2 point here, if you add this point, definitely will be somewhere in the line. Okay, and if you take 1 point here and if you multiply with some non-zero scalar, definitely it will be scaled by that scalar and it will be somewhere in the line. So obviously easily we can check that this is from a subspace of R2. Okay, you can check that this three condition will satisfy by L. Okay, at first you have to check this one. Okay, okay, so and if you take the all line passes through the origin, this is the your exact collection of subspace of R2. Is there any other subspace of R2 other than this collection?
Collection of all the circles which is zero at the y-axis and whose center lies on x-axis.
Sorry, collection of
All circles.
circles. Oh my god, you are talking about this one.
Yes, sir.
Okay, so you have to at first there in the boundary there is no zero. You are talking about this circle only or in between all?
All collection of circles, I think.
Like that, or you are talking about only this one? Only
So I tried,
this one.
it will be of not that I ask you, sir.
At first this can't be vector space because origin is not there, first one. Second one, if you take these 2 point, okay, and if you add it, it will beyond the circle, it will not be in your circle. This is the issue. Okay, so for satisfy the vector space condition, sum of 2 vector should be in that sets. Okay, so this can't be your vector space. Yeah, these two collection.
So there are no proper subspaces other than the line passing through
Yeah.
origin.
So you have to prove that there are no other subspaces of R2 other than
Line passing through origin.
or line.
So proper subspace.
Yeah, there are no other proper subspace of R2 other than, or line, you can tell line.
Or line passing through origin.
Yeah, other than line passes. Yeah, you have to prove this one. I am giving you hints, try to in your home, and next class I will tell you. Okay, so here we can say that any line passes through origin is dimension 1, only it is generating by only one element. Agree or not? What is the dimension of L? Dimension of L, what is the dimension of L? Yeah.
Yes, sir. 1.
Yeah, agree everyone?
Yes, sir.
Yeah, so dimension of L is 1. So, and L is generated by single element. Okay, is it fine? This is dimension is 1 and L is generated by one single element. Here is generated by this non-zero AB. Okay, so take suppose your S is any other subspace is, suppose suppose S is any other subspace of R2 other than through origin. Okay, so that time S can't be subset of L. Agree or not?
Yes, sir.
So S will be proper subset of. Agree? Yeah, I am taking this collection. Okay, line of passes, take this collection like L. Okay, I am removing the, and this is take L1, then it will be fine for me. Otherwise every time writing this is very difficult. Your L is the collection of all line, okay, passes through origin. Okay, so S, your S must L must be proper subset of S. It can be happen. Okay, but other way cannot be happen. Is it fine or not?
Collection of all lines which are passes through origin as well as other points.
Sorry.
S is the collection of all the points which are passes through origin or
No,
other points.
I did not mention these things. I am taking S is any other subspace of R2 other than this L. Okay. Yeah, this is you can write other than L. Okay, this is your collection. Line passes through origin. Okay, so S must be the superset of L, and you have to prove, and this is subset of R2, and you have to prove that A is equal to R2. This is your M. Okay.
Yes, sir.
Yeah, try to do in your home. Okay, is it fine or not? Please tell me, everyone.
Yes, sir.
Yeah, try
Yes,
to
sir.
do in your home. Yeah. Okay. Yeah, next class I will discuss about this one, then I'll go in next problem. Okay, do you have any question?
Sir, sir, what is next topic of the class?
I don't know, I have to think. There are few questions left, I will tell, after that I'll think.
Okay,
Okay.
sir.
Yeah, you can tell also if you want that something that some topics if you want to read, and you if you need some information on some topics, you can tell me, I'll teach you in your next live session, no issue. Okay.
Okay, sir. Sir, I ask because I can study about that topics because at that time I can't सर पूरा इतना प्रॉपर नहीं दे पाते क्योंकि सर की मतलब उसके बारे में पढ़ाई नहीं कर पाते हैं उस टाइम मतलब इतना नहीं पता होता थोड़ा बहुत नॉलेज होता है आप अगर टॉपिक बता देंगे कि नेक्स्ट सीजन में मतलब ये टॉपिक है तो उनके बारे में और अच्छे से पढ़ के आएंगे सर
Okay, so from next class I will think for next class also. Then I'll tell you. Yeah, this will be continue definitely, because I will finish this problem. This is very interesting problem. I will finish this one at first, and I will tell about little bit of subspace of polynomial space. Polynomial space is very important class for you. Okay. Yeah. So yeah, I'll talk about a little bit subspace of set of all polynomials. Okay, and
yes
I'll finish this one, after that I'll think.
okay sir
Okay, do you have any question?
Sir,